In this video, we're going to learn how to handle more complicated trigonometric equations. These are going to be ones where we need to use some sort of trig identity in order to solve it. We will still have situations where they ask for degrees. We will still have situations where they ask for radians. We will still have situations where they ask for one full circle. And we will still have situations where they want all the solutions. So all the things from the previous video are still holding true, but now we're adding an extra step of using some sort of trig identity to get the answer. Now for this first equation, you'll notice you have both sine and cosine in it, which is a bit of an issue. However, we could try to solve it like we did in the last video where we try to factor something out, but if you look a little bit more closely at this equation, there is no factoring that's going to let us do that. There is no separation here. However, when you have a sine squared and then a cosine, or a cosine squared and just a sine, we can use our standard Pythagorean identity to convert from one to the other and get it down to a single trig function. So here, we're going to turn the sine squared x into 1 minus cosine squared x. That's using the Pythagorean identity there. And now we only have cosine left. If I distribute things out here, and then I'm going to combine like terms, move everything over to the right side so I have positive coefficients. And I'm going to have 0 equals 2 cosine squared x plus cosine x minus 1. Now at this point, it doesn't really look any better than we started with. It looks pretty similar, to be honest. However, now that it's a cosine squared and a cosine, we're going to be able to factor it. So let me go ahead and remind you from algebra class, if you had just 2x squared plus x minus 1, you could factor that as two binomials. 2x times x makes 2x squared. And you're going to have a 1 times a 1 make a 1, but we need a negative 1. So one of these has to be a plus 1, one of them has to be a negative 1. And, you know, if you get good at this, you can just know right away, or you can just try 1's plus, 1's minus, and multiply it out and see if it works. In this case, it is going to be 2x minus 1 times x plus 1. We're going to do the same thing over here, but now with cosines. This is going to factor as 2 cosine x minus 1 times cosine x plus 1. So you see how it factors the same way as the regular algebra thing, but now instead we have trig functions there, and you can always multiply it out and check whether that works. Finally, we can say, well, we have two things multiplying to 0, therefore either the first thing is 0 or the second thing is 0. This first one gives me a cosine x is 1/2. Second one gives me cosine x is negative 1. We look at our unit circle here. Cosine x is 1/2 is going to be this point and this point. And those points are pi over 3 and then 5 pi over 3. And cosine x is negative 1. It's going to be this point over here. That's just pi. They only ask us for the values for one full rotation. And I see that I gave my answers in radians. And I should say, wait a second. I did not follow the instructions here. They wanted degrees, not radians. So this is not a valid answer, even though they're right. So pi over 3 is 60 degrees. 5 pi over 3 is... let's see here, 300 degrees, and pi is 180 degrees. So this is the answer they'd actually be looking for on the problem. We always have to make sure we follow the instructions given to us. Okay, next up, find all radian solutions, one full rotation, to 2 sine x plus sine of 2x equals 0. Now on this problem, we only have sine, but they're not the same sine function. One has sine of just x, the other has sine of 2x. We cannot factor them right now. We cannot solve to get the answer. Instead, we're going to have to use the double angle identity, and we're going to replace sine 2x with 2 sine x cosine x. So again, we have to use another identity this time. This time it's the double angle one. Then we can factor out the common factor of 2 sine x. It'd be 2 sine x times the quantity 1 plus cosine x. Then that means either sine x is 0 or 1 plus cosine x is 0. So sine x is 0 happens at 0 and at pi. Cosine x is negative 1 happens to also be at pi. So I mean I can write it down a second time, but it's not really going to accomplish anything. And so really we only have two solutions, 0 and pi. This time they did want radians, so I'm right. I don't have to go and change anything here. And that's your answer. One more problem in this video, and this is sine x plus cosine x equal to 0. I can't do what I did in the first problem, which is using a trig identity, the Pythagorean identity, convert from sine squared to cosine squared. I can't do that because I don't have a sine squared or a cosine squared here. I can't use the double angle identity I used in the second problem. There is no double angle here. All I have is sine x and cosine x in the same problem. And there's no factoring out that can help me here. In specifically this case, what you want to do is you want to just get sine x to one side, the cosine x to the other side, then divide by cosine x. We're going to leave behind my sine and cosine and get the equation tangent x equals negative 1. So we're turning our equation that had sine and cosine separately into one with tangent, and then we need to know where is tangent equal to negative 1. That's up here at 135 degrees. That's also down here at 315 degrees. And it did ask for all degree solutions. So 135 degrees plus 360 degrees times an integer, and then 315 degrees plus 360 degrees times an integer. Okay, so the point of this video is that yes, sometimes you're going to have to use a variety of trig identities. That's why we've been learning them, and we need them in order to solve equations that show up like this.